graphing sine and cosine. So we're going to start off by graphing the sine graph by plotting it first of all. So we're going to get our coordinates, if you like, for the values between minus pi and 4 pi. And we should already know most of these values because we've just been looking at that in our exact value section. So if I fill in this table here, I get 0, minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1, and 0. So you can see there that we are going around our circle twice because it goes to 2 pi, and in the other direction we're only going once. So let's see if we can plot that. So I can see that my biggest value for y is positive 1 and my smallest is minus 1, so that's what I've labelled my axes with. And also on the x-axis I've gone from negative pi to 4 pi. Now I'm going to start filling in some of these values. I know when x is 0, y is 0. I know when x is pi on 2, which is in the middle here, that my value is 1. And that when x is pi, I'm back to 0 again. When x is 3 pi on 2, I go down to minus 1. When x is 2 pi, I go up to 0. When x is 5 pi on 2, which is in the middle here, I go up to 1 again. And back down to 0, down to negative 1, and back to 4 pi. And the last one here, going the other direction, when x is minus pi on 2, which is there, my y value is negative 1, which is down there. And then when x is negative pi, my y value is 0. So now I pretty much have to join all those dots together. And so when I join those dots together, that's what I get. So what am I looking for? I'm really looking for nice, round, curved maximums and minimums there. Okay, so it's almost like an upside down parabola and a upright parabola. I'm looking for that sort of shape. And that is the graph of y equal to sine x with quite a few repetitions there. One repetition of it would go just from 0 to 2 pi, and it would have an amplitude of 1. But we'll start looking at that. So let's have a look at the following. So the period of the sine graph. The period is how long it takes to repeat itself. The period of the sine graph is 2 pi. You can see here that if I go like that, I am now starting to go back up again, which means that I am repeating myself. So that's why the period of sine x is 2 pi. The maximum minimum value is 1 and minus 1. Okay, and we get our amplitude from that. Our amplitude goes from the middle up to the highest point, if you like. So our amplitude for sine x is 1. What about cos x? Is that any different? Well, the graph does look different, and we're going to be looking at that in a little bit more detail. But again, it has a period, so this is the time that it takes to repeat itself is 2 pi. So if you start there and go like that, that's one cycle, and then it would start to go down again. So one period of that graph is 2 pi. Again, the maximum value and the minimum value are 1 and minus 1. And from the middle up to the top, that's your amplitude, and your amplitude of the cosine graph is 1. Have a look at the difference between these two. Okay, the cosine graph starts at 1 and then goes down. The sine graph starts at 0 and goes up. And this is something we're going to explore a little bit further. So if you like, the equation of a graph, a circular functions graph, gives away a lot of information. Just like when we look at a quadratic or a cubic in turning point form or in general form, we can get certain bits of information. So what does the equation tell us here? Well, this letter or this value in front of the sine, the cos, tan, gives you the amplitude. Remember, we've just talked about the amplitude. The amplitude goes from the middle up to the highest point. The value between the sine and the x, so this value n, is not something that we actually read off straight away. We need to use it and divide it into 2 pi to actually find what our period of the graph is. So 2 pi on n is the period of the graph. Other bits of information here talk about the translation. Where A and N we're talking about dilations. A was the dilation by a factor parallel to the y-axis, and N gave us a 1 on N parallel to the x-axis. The translation here is on the x-axis for the first one, which is inside the bracket. So x minus h, again, you'd say x minus h equal to 0, x is equal to h. That will give you a translation of h units on the x-axis. And then the last one is a translation on the y-axis by a value of k, and that is this one here. So it's a translation of k on the y-axis. As we work through some of these questions, you will see how we put that all into play. In this example, we're asked to state the amplitude and period. Now, remember, amplitude is the value in front of the sine, cos and tan. So amplitude here is 3, and the period of this graph is, well, there's no value in between the sine and the x other than 1, so it's 2 pi on 1, which makes it 2 pi. Let's go through the others. Amplitude is 0.5. Period here is 2 pi on 4, which makes it pi on 2. Always simplify it as much as you can. Here, the amplitude is 1/2, and the period is 2 pi divided by 1/2, which becomes times by 2, which makes it 4 pi. Here, the amplitude is 2.5. The period is 2 pi on 3. Amplitude is 1/2. Period is 2 pi divided by 1/4, which is 8 pi. Again, dividing by a quarter is like timesing by 4. What about this one? The amplitude is 4. The period is, okay, we're looking at this n value, so it's 2 pi divided by 2, which is pi. Why does it look different? Because you now have a translation, but that does not affect your amplitude and period. Now, this one you've got to be careful with. What I'm going to do is rewrite this so that it's in the right format. So I'm going to take the 3 outside the bracket, and that becomes x minus pi on 12. It should always just be an x inside the bracket when you want to read off your amplitude and period. So here, my amplitude, well, there's nothing there other than a 1, so it's 1. My period now is 2 pi on 3, and you can see that I've got an x translation as well. What about this one? Amplitude. Now, just because there's a negative there does not mean that my amplitude is -4. That negative is a reflection. The amplitude is still 4, so that's really important to remember. So these two are ones that you should always highlight because they are the tricky ones. And the period is 2 pi on 12 pi, yeah? There's a pi there. The pi's cancel out, and so the period is equal to 1/6. Okay, we're nearly there. Here, your amplitude is 1/3. The period is equal to, again, 2 pi on n. What's my n value? It is pi on 6, not the x, just the pi on 6. So divided by pi on 6, which is the same thing as timesing by, if you like, 2 and 1 times by 6 on pi. The pi's cancel, so 2 times 6 is 12. So there is a period of 12 there. So there's a few things that you do need to consider when you are thinking about the amplitude and the period. We're going to start sketching some sine and cos graphs, and this is the way that I would like you to think about them. All right, let's write down all the information that we know. So here, my amplitude for this is 3. Can I get you then to always write that your y value is between -3 and +3? And although you might think that that's unnecessary, when we start y translations, it'll become very important. So y is between -3 and +3. What is the period of your graph here? Well, the period is 2 pi on n. What is your n value? Hopefully you can see that it's 2. So the period of this graph is pi, or 180 degrees. Now, because we're in degrees, therefore it would be 180 degrees. So it repeats itself every 180 degrees. The other thing I want you to think about here is there any reflections? And you can see there's no negative value there in front of the sine. So pretty much it is going to be like that. That would be the trend of your graph. Okay, so how do we start by drawing this? Well, the way I'd like you to do it is to, and again, this will help you when they get harder. 3 is our maximum value there, and -3 is our minimum value there. 180 degrees is one full cycle, and we're starting from 0. Hopefully you can see your box there. All right, so here's my box. And I am going to draw a sine graph, which means I start from 0. And I know, because I'm going around in 180 degrees, that I will end up back there again. Halfway through a sine graph, you are also in the middle, so that's at 90 degrees. At 45 degrees, you reach your peak, which is halfway between 0 and 90, and between 90 and 180, so here you reach your bottom value. So if you like, my graph, and again, yours is going to be much nicer than mine. I don't really like that very much. There is one cycle of my graph. But if you have a look here, I need to go to 360. So 360 is 2 lots, isn't it? So again, in the middle, up in the middle, down in the second half, and I'm just going to continue my graph. And it looks like that. So that is the graph of 3 sine to theta, where theta is between 0 and 360 degrees. Y equal to 2 cos 3t, where t is between 0 and 2 pi. Starting to get a little bit tougher, but let's get all the information out that we know. So trend of this graph, it's a cos graph, it's positive, so it pretty much would look like that. That's what our cos graph looks like. All right, where do we go from there? We need our amplitude, and our amplitude is 2, which means that y is between -2 and +2. And the last thing that we know from this is the period of the graph, which is 2 pi on 3. Okay, so we're just about ready to go. Remember, we have to go to 2 pi, but let's just do one of the cycles first, and then we can extend it from there. So what do we know? That our amplitude is 2. So all the way up here is our cutoff, and down to -2 is our other cutoff. We are talking about a period of 2 pi on 3. So one full repetition takes 2 pi on 3. So that's where it would finish. And it starts, because there's no translations, at 0. What do we know about a cos graph? Hopefully you can see that box happening there now. All right. So we need to draw one full cycle of the cos graph in there. So with the cos graph, we always start at the top and finish at the top. And in the middle, we reach our lowest point. Halfway here we go through, and halfway there we will go through. So let me see if I can get that done. Oh, it's not very good, but yours will be better. So there's 1, and I need to go all the way to 2 pi. So 2 pi on 3, the next bit would be 4 pi on 3, and then the next bit would be 6 pi on 3, which is 2 pi, yeah, 6 pi on 3. So I'm going to have another 2 repetitions there. All right, so there's my graph. Not the best. I think yours would be better because you're going to be using a pencil and you'll have more control. But pretty much that's what your graph will look like. And we know that because it's 2 pi, 6 pi on 3, that is 3 repetitions of the cosine graph. So 2 cos 3t looks like that. T is on that axis and y is on that axis. All right, we've got one more to go. Let's see how we can finish that one. This one's got a restricted domain. Hopefully you can see that. It's actually in mapping notation. So our x values only go, or t values in this case, only go between 0 and 2. But let's just start off exactly the same way that we always have done. So what do we know here? We know that it's a positive graph, so it's not turned upside down. So the trend of this is a positive sine graph, which looks like this, starting there, going back up. All right, it's our sine graph. We know that it has an amplitude of 2. Y, therefore, is between -2 and +2. And we know the period of the graph is 2 pi on n, and n is pi in this case, so it is 2. So in actual fact, all we really want to do here is draw one cycle because it wants the domain to be between 0 and 2, and one cycle takes 2 units. So here, if I do it exactly the same way, the top, and again, these are just very gentle dotted lines. They aren't part of your graph, they're just guidelines to help you draw the graph. And here, 2 is the end point and 0. So there's the box. That's what I got to fill one full cycle in. What do I know about the sine graph? It always starts in the middle, ends in the middle, and goes through the middle like that. And because it's a positive, it reaches its peak there and its lowest point there. And we should then be able to pretty much join the dots. I don't like that, so I'm going to go back and try and do that a little bit better. Okay, and no, I don't like that either. So that's a little bit better. And I know that yours is going to look much nicer than mine. So you can see my graph there, my sine graph is drawn between 0 and 2. So we need to be very good at drawing sine and cosine graphs. At this stage, we haven't put any translations in.